A bird of prey is sitting in a tree 7 meters above the ground. It spies a snake on the ground at an angle of depression of 62 degrees. It swoops on the snake, taking 3 seconds to reach the snake. What distance did the bird fly? So if this is the ground and this is the tree, and let's say the bird is here, the horizontal, of course, is in this direction, and the bird looks down to see the snake, say here. This, of course, is a right angle. We know that this is 7 meters, and the angle of depression is 62 degrees. Now, because this and this are horizontal, we can use alternate angles to say that this is 62 degrees. The distance that the bird flies is, of course, the length of the hypotenuse here. So this is the hypotenuse. This is the opposite. So if we use car toa, opposite and hypotenuse means we're going to use the sine. The sine of 62 degrees is equal to 7 divided by d. We've seen this situation before and know that that means that d is equal to 7 divided by sine 62 degrees. So we can do that. 7 divided by sine 62. And let's just call that 8 meters to the nearest meter. In practice, when I'm doing these questions, what I normally do is write down the first few figures on the calculator display and then round. What is the speed of the bird in meters per second? We can remember back to our speed, distance, time triangle. We want to find the speed, and so that's distance divided by time. The distance we just said was 8. Let's actually use a bit more of that, 7.928. Divided by 3. So let's just divide that by 3. 2.64. And let's then just give that as 2.6 meters per second to 1 decimal place. So what I said earlier, this is often what I do. I write down sort of the beginning of what's on the calculator and then round